have learned SAQs from EMI chapter, electromagnetic induction chapter, right? So today we will see some SAQs, short answer type of questions from the chapter of ray optics. From the chapter of ray optics. From this chapter, mainly, very important one is critical angle. Define critical angle and explain total internal reflection of light. And other than based on total internal reflection of light, we have one more question is there, that is mirage formation of mirage. So, and the other one is formation of rainbow. Formation of rainbow. This formation of rainbow, formation of mirage, is both are applications of total internal reflection of light. Okay. So first of all, before we learn mirage and rainbow formation, we'll see what is a critical angle, what is total internal reflection of light, when it is occur, means what are the condition to obtain or to get total internal reflection of light. We'll see first. Then after, we'll see the application of mirage formation and rainbow formation. Is it clear, students? Right. So these are SAQs from the chapter of ray optics. Ray optics. SAQ. The first SAQ from this is, question is, define critical angle. Critical angle and explain total internal reflection of light. TIR we call shortly. So first of all, what is critical angle? Before that, we know that whenever a light ray moves, because ray optics related to the rays of light only, reflection, refraction, okay. So we'll study in ray optics, reflection and refraction in depth, right? So based on this, when ray of light moving from rarer medium to denser medium, rarer medium to denser medium. Actually, what is called rarer medium or denser medium? For a given pair of medium, because to get a refraction of light, we required minimum 2 pair of mediums required. In that pair of mediums, the medium in which a ray of light travels faster, that is rarer medium. Sorry. The medium in which light travels slower is called denser medium. Or we can say the medium which has higher refractive index is denser, lower refractive index rarer medium. And basically, we know that this is rarer medium. Let us assume that this is a denser medium. This is the line or surface which is separating two mediums. Boundary of surface. A boundary of medium. So a ray of light called incident light ray, which is coming from rarer medium, and it is enter into denser medium, so that there will be refraction of light will be takes place, because two different mediums light travel with a different speed, so that the path of light ray changes. So it will refracted into second medium. Generally, this light ray will travel like this without any medium. The second medium is not there, then light ray move in a straight line, rectilinear propagation of light. Straight line like this. But because of the another medium it is entered and that it came from rarer to denser, so it bend towards the normal. This is angle of incident we call. This is angle of refraction we call. So this is bending towards. देखो ऐसे towards the normal. ये normal line है perpendicular to the surface. So ये towards the normal आ रहा है. It bend towards the normal. Same way, this is a denser medium. This is a rarer medium. Okay. A ray of light, incident light ray, is moves from denser to rarer at a particular angle of incident I. Then it is enter into rarer medium because it is coming from denser. But while it is entering into rarer medium, bending of light takes place because refraction. But it this bend away from the normal like this. Actually, it has to go in straight line like this. So normal line here, but it is bend away from the normal. It bend away from the normal. This is angle of refraction. That means when ray of light moves from one medium to other medium, depends upon rarer to denser or denser to rarer, either it will bend away from the normal or towards the normal. But coming to our question, it is critical angle and total internal reflection of light. So for this, light has to move from denser medium to rarer medium because it bent away from the normal. Away from the normal. So what will happen while ray of light moving from denser medium to rarer medium? Denser medium to rarer medium. As we keep on increasing the incident angle, as we keep on increasing the incident angle, this I, while it is going from denser to rarer medium, then what will happen means, then keep on the refraction angle that is bending away from the normal ray of light. It also bend more away from the normal. That means refraction angle also increases. So as we increase the incident angle, refraction angle also increases. That will more, it will bend more away from the normal. Okay. Then from this, how we'll define critical angle and total internal reflection of light? We'll see now. Just this is explained to you what is basic bending of light towards or away from the normal. Now, actually, what is answer for this question? We'll see now. First, a ray of light is moving from denser medium to rarer medium, and we are keep on increasing incident angle. And due to this, the ray bend more away from normal as shown. Okay. So as shown, the diagram I will draw here. Understood? A ray of light is moving from denser medium to rarer medium. And we are keep on increasing the incident angle. Due to this, the ray bend more away from the normal as shown. Right? So what is diagram we'll see here? Look here. This is denser medium. And this is rarer medium. Okay. Here one we have source of light. from which light rays are coming. Source. So first light ray I'm taking normal to the surface. So normal to the surface means it will not bend towards or away from the normal. Without deviation, it will travel into the dense, rarer medium. Now from this means angle of incident is 0 here. Angle of incident is 0. Then from this, we slowly increase the angle of incident. That means initial angle of incident 0. Because angle of incident and refraction angle are measured with the normal. So this line is perpendicular to the surface only. That means along the normal only. That means angle of incident with the normal is 0. So from this 0 angle, slowly will increase the angle of incident. What happened to the behavior of refracted light ray? We'll see. Okay. So first, I'm taking with some angle of incident. Something like I1 angle. So that it will bend away from the normal. We know this is angle of R1, refraction angle R1. Okay. Now again, one more light ray I'm taking, which is somewhat greater than the previous incident angle. That means I'm taking it as I2, which is greater than I1. Greater than I1. So that what happened? It will bend more away from the normal as compared to previous one. Correct? That means it will bend more away like this. This is R2, which is also greater than R1 will come. Okay. So like this, what happened? You see, ray of light going from denser to rarer, denser to rarer. Okay. Then bend ray of light, refracted light will bend more away from the normal. You see, more away first, like this is there. It will bend like this. It will bend like this and keep on increasing. At certain moment, it becomes horizontal. The refracted ray becomes horizontal, or it is grazes the surface which is separating the two mediums. It grazes the surface. Along the surface, it will move, or along the boundary which is separating two mediums, it will move. Correct? So that means like this. For this situation, let us consider this is a situation which is I3 angle, okay, which is greater than previous angles. And we got for that ray of light grazes the surface. That means it is along the boundary of the two mediums. That means the refraction angle, if you see from the normal is vertical line, refracted ray is horizontal line. So what is angle between vertical and horizontal? 90 degree. That means here the corresponding angle of incident refraction R3, that is exactly 90 degree. Exactly 90 degree. Correct? Now, this particular angle of incident where the refracted ray grazes the surface, or it moves along the surface, or the refraction angle is set to be 90 degree, but the corresponding incident angle is called critical angle. What we call? Critical angle. So this angle only we call critical angle, because for this angle of incident we are getting refraction angle is 90 degree. Correct? Okay. Critical angle definition we got. That means a ray is moving from denser to rarer medium. For what angle of incident? The refraction angle is said to be 90 degree. That angle of incident we call critical angle. Clear? Okay. Now what we will do? Furtherly, we'll increase the incident angle, which is moving from denser to rarer. Denser to rarer. So furtherly, we increase the ray of light, furtherly increase the angle of incident, which is greater than I3, nothing but greater than critical angle. So what happened? At critical angle only, the refraction angle 90 degree we got here. At critical angle, we got refraction angle 90 degree. That means the refracted ray like this is horizontal is there. So furtherly, if you increase the incident angle furtherly, that means greater than critical angle, then previously 90 degree refraction angle, it will bend more away. That means greater than 90 degree will come. Greater than 90 degree. But greater than 90 degree means the ray is coming from denser, and again it is bounce back to the denser only. Means coming back to the same medium only. It is not entering into another medium. Correct? See, for critical angle only the refracted ray horizontal. More than critical angle, if you take this horizontal line, become down. Down means it is coming back to same denser medium. The incident light ray coming from denser, and the refracted, or we can say that is reflected ray coming back to the denser only. That means the ray bouncing back to the same medium after striking a surface. That is called reflection. But normally reflection means polished surface. From polished surface we'll get. But यहाँ पे कोई polished surface नहीं है. Denser से rarer. There is no polished surface. Transparent surface is there. But still, for a different, particular situation, for a different condition, greater than critical angle, still the ray of light bounce back to the same medium, called reflection taking place. And this kind of reflection we call total internal reflection. Back, internal mat फिर से वापस आ रहा है. Internal reflection. That means यहाँ पे ऐसा reflect हो जाएगा. The refraction, you know, incident angle is equal to reflection angle. यहाँ पे I3, I4 है तो यहाँ पे भी reflection angle भी I4 होगा. समझ में आया? Diagram is clear. This is only explanation only. Remaining we have to write whatever we have said. It is orally. We need to write in a word. That's it. The complete explanation and the definition of critical angle and explanation of TIR is done here by using diagram. Now, what only we have to do? Only the definition of critical angle and what is TIR we need to write. Clear? Diagram, everybody clear? Yeah. Now, more away from the normal as shown. That is as shown. So now critical angle definition will write. That is IC. I means incident angle, C means critical. Critical angle. So when light ray moves from denser to rarer medium, the angle at which you want, you can write the angle of incident. The angle of incident at which refraction angle is said to be 90 degree is called critical angle. Is called critical angle. Clear now? When light ray moves from denser to rarer medium, the angle of incident at which the refraction angle is said to be 90 degree is called critical angle. Okay. Then we'll take the critical angle. Here something denser medium I am taking as something like a refractive index mu. And this is rarer medium like something like air I am taking. So refractive index of this air is 1. Okay. Then the critical angle for this particular pair of medium I can write by using a Snell's law. By using a Snell's law, I can write sine of critical angle will be equal to reciprocal of refractive index of the denser medium. Refractive index of the denser medium. That implies critical angle will be equal to sine inverse of 1 upon refractive index. 1 upon refractive index. Clear now? So this is definition of critical angle. Now coming to the TIR, total internal reflection. TIR, total internal reflection of light. So as usually, as same, when ray of light moves from denser to rarer medium at angle of incident more than critical angle, then the ray get reflected back to same medium. That is, from which medium it is came, that is denser medium, into the same medium it is get reflected back. So this is called TIR. This is called TIR, total internal reflection of light. So student, is it clear with the neat diagram, critical angle definition and TIR? Clear now? Any doubts, students? So students, is it clear? That question is clear. Before moving into second question, so if you have any doubt regarding this question, you can ask. Or you can raise your hand. Those you have a doubt, you can raise your hand. Yeah. So student, nobody have doubts, right? We'll move to the next question. So this is critical angle and total internal reflection of light. Second question is, we'll discuss formation of mirage. Okay. One of the optical illumination or optical illusion, which will generally occur in summer days. Very hot summer days we can say. Okay. See now that question. अच्छा ठीक. ये लाइन दिख रहा है, नीचे पूरा दिख रहा है ना, ये लाइन दिख रहा है, नहीं आ रहा है ना. Right. ये पूरा कवर कर रहा हूँ. Okay. So let us, student, next question it is. Explain formation of mirage formation, or explain formation of mirage. Explain formation of mirage. What is this mirage means? So it is one of the application of TIR, total internal reflection of light. Total internal reflection of light. So we can write first point here. It is a application of TIR, total internal reflection of light. It is application of TIR. We know TIR means when light ray moves from denser medium to rarer medium, it keeps on, as you increase the incident angle, it keep on increase the diffraction angle. So at one particular angle of incident greater than critical angle, the refracted ray or it get back to the same medium. That phenomena called TIR. Same way, normally during hot summer days, okay, or when you're traveling on desert, or when you're traveling on express highways. So you will see when you're traveling on express highways during hot summer days, so you will feel that there is a pool of water on the road. A pool of water on the road. It is an optical illusion. Optical illusion due to TIR, total internal reflection of light. Actually, how it is formed, you see, diagrammatically first we'll see, then after that we'll explain the points. So during hot summer days, the air above the ground or near to the ground as more hotter than the upper level. The upper level like that. And one more upper level is more, suppose for example, if you see, this is a ground. Then I consider during hot summer days, the air I divided into layer by layer, like this. So this is ground. This is ground. From this, above one line is there. This line is more hotter. It is less hotter than the ground. And this level is more hotter than this line. And again, this one is more hotter than this one. That means if I take it is ground 0, this is 1, 2, 3, 4, 5, 6. 0 is more hotter than 1, and 1 is more hotter than 2, or 2 is more hotter than 3, and so on like this. So that means air is more hotter than other layer, which is very near to it. The air is very hotter than the above layer. That means the layer which is, the two layers if you take, the layer which is hotter called rarer medium, and the the layer which is somewhat cold than the remaining layer is called denser medium, because the hotness will increase the rarerness. That is, rarer medium will get, and temperature less means denser medium will get. So due to that, when you going from ground to above some height, then keep on you are going from rarer medium to denser, rarer medium to denser, rarer medium to denser, rarer medium to denser, if you are going like this upper. But reverse, if you see somebody coming like down, That means upper level to lower level you are coming. Upper layer to lower layer you are coming. That means you are coming from cold region to hot region. Cold region to hot region. Like that. That means denser medium to rarer medium. Denser medium to rarer medium. We are moving. So in this situation, if we allow a light ray or a light ray coming from tall object like tree, tall object like tree from the top of the tree, then that light ray has to go from upper layer to lower layer only, upper to lower end. That means denser medium to rarer medium it is going, right? So that means denser to rarer is going and refractive index continuously decreasing as we move from above to lower. That means upper to lower you are coming, continuously the refractive index decreasing. So there will be a possibility of TIR, total internal reflection will be takes place. So for that, I will explain by taking one diagram of tree. See, I am taking one diagram of tree. Okay, this is ground. Okay, then somebody are going like this. Refractive index, that is mu, decreases. Refractive index mu decreases. Then whenever light comes from this tall object, so light coming from this top of the object, so it goes on down or goes on towards the ground, That means it goes on moving through decreasing refractive index mediums. That means towards rarer medium is going, denser to rarer is moving. That means at particular moment or particular point, there will be a possible of TIR takes place where incident angle greater than critical angle. That means you see, a ray is coming from top, like this, it bends, like this comes, it will bend away from the normal, and it will bend toward, and total internal reflection will be takes place like this. And here one observer is there. Okay. And observer is there here. For him, so we feel that generally light comes from straight line because light has a propagation of rectilinear propagation. For this observer on ground, he feels that light comes from down to the ground. Actually, it is coming from top of the tree, but it is appeared to comes from lower. That means the image of this tree for this observer, it is appeared as inverted. So like this. Here the tree appeared as inverted. So this kind of phenomena is called mirage. That kind of object tree is appeared as an inverted position. That kind of phenomena is called it as mirage, and it is formed during hot summer days. And it is application of TIR. Clear now? So simple. Whenever light comes from tall object like tree, it successfully moves from higher level to lower level, which has continuously decreasing refractive index, so that light rays move from denser to rarer continuously, and certain point, and there will be a TIR, total internal reflection will be takes place. Correct? So that we call it as mirage formation. So what we have to write here? When, so, or we can say it forms during hot summer days. And the layer of air just above the ground as lower temperature than the ground. Like that, if you take another layer above this layer, then this will be become very hotter than that one. So that means from this we can say, if you are going from top of the object to ground, from height to ground, if you are coming, you are moving in the direction of higher refractive index to lower refractive index. Higher refractive index to lower refractive index. Okay. So you copy this one. I'll continue this one more point I need to add here. Okay. So another point, what it is means. When light ray comes from tall object like tree, it moves from denser medium to rarer medium or refractive index of medium gradually decreases. Okay. So due to this TIR takes place as shown, and it is called mirage. Okay. This is formation of mirage during hot summer days. Student, any doubts are there? Regarding these two questions today, what I explained. So do you have any doubts? So those who have doubts, you can raise their hands. Any doubts, students? Okay, good. So these are two questions. So rainbow formation is another question from the chapter. So that we will discuss tomorrow. Okay. Rainbow formation will be discussed tomorrow, because again, if you start also, it will not complete. So better we can start tomorrow. Clear?